The Analytics Workbench allows you to prepare, analyze, and visualize data all within a single work environment. Once you are logged into the Data Hub, the Workbench will include several services, all within the cloud environment, including SAS, Jupyter Notebooks, so that you can code in Python or R, as well as Data Wrangler, a no-code solution with over 300 built-in data transformations to analyze and clean your data to prepare it for machine learning. Each one of these platforms were selected for a variety of technical backgrounds, whether you code or whether you don't. So next, we'll take a look at a live demo of analyzing data. So when you first come to the SageMaker Studio page, you have a couple of different application options. On the left-hand side, you can see 5 different applications to choose from. The JupyterLab environment allows you to create, manage, and run instances of JupyterLab spaces. This is primarily for running Python or R code, as well as IPython notebooks. The code editor is Visual Studio that's been wrapped in a browser interface if you are running any programming languages that are not Python or R, including JavaScript and Java. So let's take a look at the JupyterLab space. When a user first comes to this page, they can either choose to create a JupyterLab space on the top right-hand corner. And you can also see a list of existing spaces. So each one of these spaces has a definition, whether it's private or shared. When you first create a space and give it a name, you can choose whether it's a private space that's only accessible by you, or a shared space that's shared with all other users in this domain. This is primarily for public access for all users that are on the Data Hub. So we'll take a look at data space here. You can click Run to start the data space, and you can view the status of that space as it initializes. So this takes a couple of seconds to minutes. While we're waiting for that to load, let's take a look at some of the help guides. So on this page, you'll see a quick user start guide that'll point you in a direction of how this instance runs, how much data you can put on it, as well as any configurations that you need to set up your workspace. All of this is pre-installed so that you won't have to do anything outside of the box. What comes in the workspace is a couple of common Python libraries, such as TensorFlow, PyTorch, Keras, and scikit-learn. These are all very commonly used for machine learning, as well as NumPy for your matrices modeling, and pandas for data frames. So once it's ready to initialize, we click Open to navigate to JupyterLab in a new tab. On the launch page of the JupyterLab notebook, you'll see several options. So you can choose Python 3 to open a new Python notebook. In these notebooks, you can run code cell by cell, as well as generate output directly in line. So let's see what other options we have. In the environment, some of the synthetic data we saw on the public data page is preloaded by default for all users. So when you open some tabular data, you'll be able to view it directly in the page. Here we have some synthetic COVID-19 data generated by Synthea, just a 10K sample. Here's an analysis notebook that goes with this data set to provide an example of the cells, how to import libraries into your notebook, primarily the ones that are pre-installed, and then read in that data as a CSV file, run an analysis on that data, as well as print out any outcomes of the data. As you can see, this kind of notebook is very helpful for both sharing your code and annotating it with comments, as well as showing graphs and plotting them directly in the notebook. So next, we'll take a look at another feature that allows you to bring in your own code. So from the panel on the left, you can create your own folders to organize your data, or you can upload data directly from your local machine. You can refresh the file browser as new data sets are loaded in, or you can bring in data from a GitHub repository using the GitHub plugin button. So here we can see it's asking for a GitHub repository URL. So we'll go here to this GitHub repository called Amazon SageMaker Examples. Copy the URL here and click back into the tab to clone this data set. So when you first clone a GitHub repository, a new terminal window will open, displaying the progress of downloading that GitHub repository. As this is running, we can take a look at some of the other features in the notebook. On the second tab, you can see which tabs are open and choose to close them all. You can see which kernels are open. And once the data set is loaded, it automatically opens the folder for you. So let's take a look at one of these SageMaker examples. So you can either navigate to these directly from the folder, or you can navigate them from links within the notebook. In this example, let's go to applying machine learning, a population segmentation of US Census data. And it looks like it may be a broken link, so let me open it from the folder instead. Here we go. So in this notebook example, you have a couple of options. The kernel that's being run on the top right is Python 3. However, you can select from a couple of other kernels, including R here. At the very top of this notebook, you see the dependencies that are installed or the libraries that you can bring in. An introduction to this analysis, this data source, as well as the steps in this data science workflow to clean the data, visualize it, and apply some feature engineering. And then the second portion of this data analysis runs a dimension reduction, a PCA model, which is principal component analysis, and K-means modeling. All of this can be done within one single notebook. As we can see here, we're calling some code to load in the data from an S3 storage bucket. In the exploratory data analysis portion, we can directly call some of the libraries to perform data transforms before visualizing the data in a histogram. And each one of these cells can be run inline so that you can go and step through the code one by one. This is really helpful if you're just running some exploratory data analysis or debugging as well. Let's jump back to the launcher. So in this interface, we have a new tool by request called Data Wrangler. It operates within an application called Canvas. So when we open Canvas, we can see that it's a new tab that brings you to a page with several get started actions. All of these provide access to machine learning and generative AI models with no coding required. So let's take a look at what some of these ready to use models are. In the Canvas interface, we have create a custom model, or you can use pre-existing ones. As we can see, there's quite a few models for text analysis, image analysis, as well as document analysis. Let's go to an example data set here. All of the sample data that's loaded here is tabular, so we'll select a sample diabetic readmission CSV. You can open up the tabular data directly inline. And from that data set, you can choose to merge this with other data sets as well, or you can create a data flow from this data set. When a new data flow is created, you can control the overall view from a pipeline. This way you can add steps to your pipeline if there's multiple different transforms necessary to clean your data set. One of the newest features out of this tool is Get Data Insights. It automatically identifies data quality issues and recommends data transformations. So when we create an analysis, let's give this a name. Let's choose a regression model outside of the box. And these are quick models that are available. Choose a target column in this data set. We're going to choose age. And this report automatically generates some summary statistics about the data, the percent missingness from the code, as well as any duplicate rows. It runs validity checks on your data and enumerates the types of data that are available. There's 8 that are numeric and 4 categorical. No high priority warnings were found in the data, nor duplicate rows. The next section shows an anomalous sample overview using an isolation forest algorithm. It identifies these anomalous values for any outlier detection. In the target column, we see some summary statistics about the mean, the max, the median of this age group, and then a histogram of the target column for age. As we can see, this histogram shows a majority of the ages for diabetic readmission is over 50. The quick model also provides an estimate of the predicted quality. Several metrics are generated, such as the R2, MSE, and RMSE, and validation scores, as well as training scores. By default, the data is split in by 80-20 for 80% of the samples for training and 20% for validation. Canvas uses a XGBoost model by default. However, this can be adjusted in your settings. Under the feature summary, it enumerates each of the features that were available and orders them by predictive power. This indicates which feature is most meaningful for classification. The top 3 listed here for diabetic readmission is the number of diagnoses, the number of procedures, as well as the A1C result. And the scores are normalized within a range 0 to 1. As we scroll down, There's a further breakdown of each of the feature details. For the number of diagnoses, we can see a histogram of this feature with the corresponding target distribution by age. Each of these graphs are interactive so that you can take a closer look at that feature value and any corresponding correlations between the feature and the target value. Standard deviations are calculated as well for categorical results. As we can see here, none was 80% of the frequency for the A1C result. So although it said it wasn't missing, there is value to taking a closer look at each of the values. And this indicates an area of improvement for finding missing values in your data and sparseness. Here's an example of time in the hospital as a numeric value. Towards the bottom of this report, we see rare classes. So rare classes are ones that could lead to overfitting and subpar prediction performance. It provides a recommendation to consolidate these into a single category, as well as the transform to perform, and where you can find it. Under handle outliers, it recommends to replace these rare values. The bottom of the report defines the feature types as well as the feature statistics that we saw. A definition is provided for predictive power, for the quick model metrics, as well as explanations of how each metric was calculated. Any classification that is used for accuracy, receiver operator curve, area under the curve, and F1 scoring. So a full evaluation of the model is generated as well in this report within a matter of minutes.